Hi, so in this video I'm going to talk about Bitcoin, more specifically why it is needed and how Bitcoin solves some problems in our current financial system. And also I'll go a bit deeper into the technical details of Bitcoin. So first of all, why is it needed? So before I go into the details, I would like to mention certain properties of the current financial system. Okay, so currently what do we have? We have banks and we have currency. So what do banks do? You put your money in the bank, and whenever you want to transfer your money from yourself to someone else, you kind of do authentication and then you instruct the bank to transfer certain amount of money. So let's say you have $10,000 in your bank account and you want to transfer 5,000 to your friend. Then what happens? The bank actually checks if you have enough money to transfer $5,000, and the bank sees that okay, yes, you have $10,000, so you can transfer 5,000, and then it basically does the transfer from A to B. So what all things happened here? First of all, there is this verification step which bank does so that you don't spend more than what you can afford to spend. Okay, so you have 10,000 and you trust the bank that it keeps the money safe, and the bank does this check for you whether you are able to transfer or not. And what are the properties of this overall scenario? So currently the banking systems are electronic in nature, which is good for us. So we can basically sit at your home and do any kind of transfer we want. But there is another thing, which is the fact that the bank is centralized. So you trust that the bank will store the money you have and it won't run away with your money or do something else with the money. So that is one aspect. The other aspect is the verification. So bank verifies that it is truly you who is spending your money and no one else. So that is also another important aspect of the current financial system. So this is what the bank is. Next comes currency. So what's the issue with the current way the currencies work, for example the US dollar? So the thing is that it is completely government controlled. So the government can basically decide tomorrow to print more money and thereby driving inflation. So this basically again comes to the centralized aspect of the financial system. So many currencies, or if not most currencies, are inflationary. And this is a problem, right? Because if you have $10,000 today, and if there is inflation, maybe after a month, this $10,000 will be worth $9,000, if not less. So it is important that inflation remains under control. Ideally, there should be no inflation or deflation, but if there is unlimited inflation, then that is of course a problem for you. Another thing is that practically it has unlimited supply. So the total amount of money keeps on increasing as government keeps on printing more and more money. So that also needs to be addressed. So an ideal financial system should be electronic, should not be centralized, and it should be easy to verify when you are doing any transaction. It should not be inflationary, and it should not have unlimited supply. So its total number of coins per se, a total number of, let's say, US dollar, it should not continuously keep on increasing all the time. That is not good for the economy. So that's what we ideally need. One may say gold is an alternative because gold has fixed supply, so it is not unlimited supply, and you can hold gold. So it is, you are having the gold, so you can verify. But it is not that centralized because most countries, they recognize gold. But one issue is that it is not exactly electronic, so you cannot really transfer the gold you have in a few seconds to somebody else. So that is one issue with the gold. So that's why being electronic is also important. So if we think of something which is electronic and decentralized. What does that mean is that the corresponding cash will be in the form of will be electronic. And what does decentralize mean here? So decentralization would mean that bank or one particular bank will not be in the sole authority to approve or disapprove your payments or even hold your payments. So how to do that? So what does bank really have? It really has a ledger on your behalf where all the data are written. So let's say you made a transaction A to B, then A to C, then A to D, and all these records are there. And starting from, let's say you had $10,000, and then all the subsequent transactions are kept in the record in a bank. So that is the centralized aspect. How can I make it decentralized? I can make it decentralized by sharing this record across multiple entities. So all of them have the same data. So let's just say these entities are different computers or nodes. So all of them have this data. So all of them can verify how much money you have currently and if you are able to transfer something which you can actually afford to transfer or not. So this is how we can go from central entity to a decentralized system, but it has a couple of challenges. First thing is the verification, and the second one is something called double spending. So verification was easy in the case of an electronic bank because the bank knows your email ID, password, and few other details so that it can easily verify you. But how will that thing work in case of a decentralized system? Because if everything is shared, then someone can act on your behalf and make a transfer which you did not authorize. So how this problem is solved in case of Bitcoin? That is by using something called private key public key pair. So what happens in this case is that everyone has his own private key, which is like a password, but the public key is public. And let's say if I'm making a transaction from A to B, if I am A and I'm making a transaction to B, anyone should be able to verify that I truly am the person who is doing it and no one else will do it. And this is possible by using cryptography. So how that works is that there is something called hashing, which is like a function where if you take hash of any data, then it can always result in a 256-bit character. Okay, so this is the property of a hashing function. You can hash any kind of data and you can get a data of the exact same length. But in case of cryptographic hashing, the opposite is not possible to do. You can't start with this 256-bit data and go back to the original data which you hashed. So that is the overall idea that is used in this case. To be more specific, when you are making a transaction, you have to sign the transaction. And how do you sign it? By using the hashing function where you have your transaction message and your secret key, which is your private key. Okay, and once you use this function, you get a signature. But as I said before, from this signature you cannot get the secret key easily. It is like extremely difficult to go the opposite way. So if I see this signature, I am able to verify that the owner of this secret key created this signature and no one else. And that is done by another verification function which takes the signature as input and the public key, and this gives a true or false. Okay, so what we did here, we have a transaction here which you sign, and then that thing can be verified by anyone. So this solves the verification problem, because when you start a transaction, you basically broadcast into the network, and all of these nodes which are there in a decentralized manner, they get your transaction, and all of them can do the verification that you truly are the one who did this, and they can obviously check how much money you have currently and if you are able to actually spend it or not, which is basically verifying the authenticity as well as the feasibility of the transaction. So this is how the verification problem is solved. The second problem in case of a electronic decentralized system is double spending. So for now I have only mentioned one transaction, but what happens in case of Bitcoin is like there are like many transactions which go on and we batch them together into blocks. So we have a block which have lots of transactions, transaction 1, transaction 2, then the next batch of transactions we basically build on top of this, which is like, let's say, transaction 3, transaction 4, but this second block, this, let's say, nth block, this is n plus 1, this second block, it stores a reference to this nth block. Okay, so all blocks are built on top of the previous one. And the problem of double spending is like the following. So let's say you have an electronic item, let's say I have a JPEG image, I can send it, the same image to you, I can send it to 1,000 other people. So how are we going to check that I'm not double spending it? So part of the problem is basically by through this verification issue, by this verification solution which I just discussed, through which anyone can verify that if I'm actually double spending or not. The other part is that, let's say you are one of the participating nodes, like one of these nodes, and you are trying to game the system by maliciously adding more and more blocks, in which case you are writing such transactions which are like not possible or did not happen. For example, you can write in a transaction that somebody else gave you certain amount of Bitcoin and that actually didn't happen. So to solve this issue, there has to be a solid concrete way to decide who gets to write these blocks. So what happens when a transaction is communicated? So all of these nodes, they get different transactions in different order. So there needs to be a way to decide who gets to write and in what order. And this issue is solved by Satoshi Nakamoto by something called proof of work, which is basically you have to solve a problem, a complex problem, and whoever solves it first gets to write the next block. And I will go into more details of what problem it is a bit later. But what happens is that it is very, very difficult to be the first one to solve this problem continuously. So you might be able to solve it once, but the chances of you solving it back to back while competing with the other nodes who are also trying to solve the problem, that is extremely hard, unless you control more than 51% of the whole network. So coming back to the double spending problem, in case let's say we have a few blocks until here, and at this point a malicious actor gets to write an unfair block and tries to build on top of that. At the same time, because he was the one who got to write this block in this round, this blockchain or chain of blocks, they are communicated to the other nodes. But in the next batch, he may not be the one who gets to write it. Okay, so somebody else might be the one who actually gets to write it. So there will be like a fork. So somebody else will see that, okay, this is not a valid block, so he will start building on top of this one, which is the last proper valid block. And eventually there's like a tiebreak mechanism to decide which chain to actually select. So eventually what will happen is that the nodes will start building on top of the correct blockchain, not this incorrect malicious one, and eventually this portion will be discarded. Okay, so this is how the double spending problem is solved in case of Bitcoin, as well as it is ensured that the sanctity of the network is maintained by something called proof of work. And you may ask why these nodes are actually doing all this hard work. That is because if they are writing a new block, they get some new amount of Bitcoin. So per block one may get like around 12 Bitcoins. I mean, this number keeps on varying. So after every certain number of blocks, the number of Bitcoins that is available per block, that gets halved. That's called halving. So they get reward in terms of new Bitcoins, as well as something called a fee, which you need to include every time you send a transaction. For example, when you use, let's say, PayPal, PayPal takes a fee. Similarly, if you are sending a transaction in the Bitcoin network, you may choose to add a fee which will go to the miners. So these nodes which solve this problem, this proof of work problem, to keep on adding these new blocks, they are called miners, and you can add a fee in your transaction to pay the miners. And because this number of Bitcoins that is available per new block, that keeps on decreasing with time, so the total number of Bitcoin is fixed to 21 million. That's the way it is designed. So there will never be more than 21 million Bitcoin, which means this solves this inflation problem, because the total amount will always be fixed. So if anything, it is deflationary, not inflationary. And it is of course electronic, and it is decentralized by the fact that all of these nodes are saving your ledger data in the form of these chain of blocks or blockchain. So this is how the decentralization is taken care of, and it is not centralized. The verification we discussed, the decentralization we discussed, it is electronic, it is not inflationary, and it is not in an unlimited supply. So this is how Bitcoin solves all these issues of this current financial system. The only issue for now is the fact that it takes a lot of electricity, which is not good for the environment, but there are other blockchains which solve this issue. So now finally I will mention what is this problem that these miners try to solve. So let's say there is a block right now which has certain transactions, and there is this reference to this previous block, and there is a new block that is going to be created. So what does the new block have? It will have the transactions which you need to include. It will have the reference to the previous block, the previous block hash, and there is something called a nonce, which is just a number which can be 0, 1, 2, or any big number. So what these miners are trying to do is they're trying to find the value of nonce such that the hash of this nonce, as well as this other information which needs to be there in the block except these transactions, becomes such that it starts with certain number of zeros. So how many number of zeros, that is decided by how hard the problem needs to be, but that's for some other discussion. So let's say that number is 5. So we need to find this number so that hash of this entire thing starts with certain number of zeros. So one may try to take 0 and check it didn't happen, then one will do with 1 and check it didn't happen. So it's basically brute forcing, and because it is like pretty much brute forcing only, so it is kind of directly related to the amount of computing power you have. And this is how Bitcoin becomes proof of work, because you are actually doing this computation work to solve this problem, and once you solve the problem, then you get to write the transactions which you receive. So the transactions which miner 1 receives may not be in the same order that miner 2 receives. Okay, so this is why there is some bit of fuzziness, which is why it takes certain amount of time before a transaction is fully finalized, because fully finalization means all these participating nodes should have consistent data and not like divergent blockchains. Okay, so this is a brief overview of what proof of work includes. So we basically discussed how Bitcoin solves all these problems of having an electronic payment system which is not centralized, which is verifiable, which is not inflationary, and not unlimited supply. If you have any questions, feel free to write. Thank you.